All righty. Well, okay, there we go. So our recording has started. Thank y'all for sharing some of your favorite hobbies. Oh, photography. Okay. I wish I was good at photography. Fishing. I like that, Ben. Fishing is super fun. If you catch something. If you don't catch something, it's really boring. Nola, swimming. I am a terrible swimmer. Oh my goodness. It's bad. It's bad, bad. Alrighty. So let's go ahead and Michael, you like swimming too. How fun. All right. I'm going to leave the chat open. Um, table 1 is a function. Table 2 is a relation. So I want you to take just a few, like maybe a minute, a couple seconds, and look at these two tables and tell me like what you notice is different, and what you think might be different about a function and a relation. If you watched the video in the course yesterday from the lesson, you probably know the answer. So anybody? Oh, good, 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 good. Y'all are smart. Yeah, good. So table 1 is a function because each of these x values is different. Table 2 is not a function because -1 repeats. Y'all are good. Nice. You guys were paying attention in class yesterday. All right, so let's go over some of the differences between a relation and a function. A relation is a rule that pairs each element in one set. So it pairs the x values, which is also called the domain. It pairs each domain with one or more elements in the y's, which is range. Exactly, Amari. Y's can repeat, yes. X's cannot if it's a function. If it's a relation, then they can. But we're mostly just determining whether or not something is a function. So a function then pairs each element in the domain or all the x values to exactly 1 in the y values or the range. So I'm going to make a little note here. Domain is x, range is y. So as you can tell from this mapping, this first one is a function because each of these 1, 2, 3, and 4 have exactly 1 pair in the range or the y values. This second one is not a function because this number 3 has 2 different y values that it's going to. Okay, so 3 is repeating, so therefore it is not a function. And I want you to tell me about this third one. We'll call it number 3. I'm going to put up a quick little poll here. What do you think? Green check for function, red check for not a function. Good, good, good. So most of you said it was a function. Yeah, 3 is in the last one. Thank you. It is a function, yes, because even though the x's 1, 2, and 3 all go to 6, that's okay because the x's itself is not repeating. Okay, so today we're going to practice identifying functions, and then we're also going to evaluate functions. So yeah, Micah, thank you, Sean, for helping me. I missed that comment. A function doesn't have repeating x values. So the y value can repeat, but the x values do not. All right, so I want to do a warm-up. This goes back to I don't know when you might have learned to write coordinates of the ordered pairs, but we're going to go over it really quick. So ordered pairs are written as x, then y. So you're going to start at your origin or 0, 0. Good. And the first value for a would be 0, 4. Yep. All right. Do I have 5 people that want to raise their hand and you can do the next ones? Awesome. Thank you. Okay. So I'm going to put your initials here. Thank you, Micah. Anybody else want to do one? All right. I'm going to double some of y'all up then. All right. Let me give you guys whiteboard tools. And you can go ahead and write out your ordered pairs for me. If you are not doing it on the board, go ahead and write these down on your own, and then we'll check and make sure that our friends got them right. Hey, Ben, I'll go over that with you after class if you want. Okay, will you ask me that question about what assignments to do? All right, so be double checking your answers with the answers that they have put on the board. All righty, so let's double check them. For B, we've got -6, 0. Excellent. For C, we've got -4 and -4. Good job. For D, we've got -2, 6. Exactly. For E, we've got 5, 2. Perfecto. And for F, we've got 2, -4. Yay, y'all did awesome. Thank you so much. So any questions about any of those points? So the reason that we're working on that is because we're going to start evaluating some functions. We're going to be looking at a graph like this, and we're going to be talking about functions, and we're going to need to be able to write a function in various forms. So let me show you what I mean. So on this one, it gives us the function as a mapping. What you can do with a function or a relation, doesn't necessarily have to be a function, but you can take this information from the mapping and we can actually represent this relation as a graph, as a set of ordered pairs, and as a table. So the first thing we're going to do is write it out as a table. So we would put the x value, -2, and that one pairs with 7, 5. When x is 5, y is 4. So this is our x values. These are our y values. When x is 1, that repeats twice. So when x is 1, y is 3, and it is 0. So now we're going to write them as ordered pairs. Some of y'all have been doing that. That's great. So we've got negative. I didn't leave myself very much space here, did I? -2, 7, 5, 4, 1, 3, and 1, 0. And then lastly, we're going to go ahead and graph this. So we would go 2, and 7 is going to be kind of off. Oh, it's, yeah, -2, 7, 3, 4, 5, 4, 1, 3, and 1, 0. So we can represent relations and functions in different ways, okay? So if I give you one piece of information, you should be able to write it as an ordered pair, table, mapping, or graph. All right, so we know how to check if something is or is not a function on a mapping or a table or a set of ordered pairs, right? We're looking for a repeating X value, and we have a repeating X value in 1. So that's pretty easy to see on a table, a mapping, or when you have a listed out set of ordered pairs. When we are looking at a graph, we are going to use what's called the vertical line test. So I'm going to attempt to draw a straight line. We'll say that that's close enough. And I'm going to write it out here. Vertical line test. Okay, so you can do this with your pencil, your finger. You can just kind of pretend that you have a vertical line. But what we're going to do is we would take this line and move it across. So every time I touch a point that's on the graph, whether it's continuous, meaning it's like a line that's all connected, or it's discrete, which is like this one, it's broken up. I want to make sure I'm only touching that point in one spot. So it only touches there. So far, so good. As I keep moving it across. When I get here at x equals 1, this is where I have it crossing 2 times. So therefore, it's not a function. Okay. So when you are given just a graph and it asks you, is this a function? That's when you're going to use the vertical line test. Okay, let's talk about some other vocabulary words we're going to need to know. Dependent and independent variables. So the dependent variable changes in response to another variable. So the dependent variable is our y value, okay? Or sometimes it is represented as f of x. Okay, that's going to be our dependent variable. Alrighty, so then our independent variable is going to be our x. So the independent variable is what we change. We plug in something new, and then that forces the y value then to change. Questions? Okay, so let's talk about how we would use this then in the real world. So does anyone in here have a job that you do? No, that's okay. If not, I am going to make you all employed for the next 5 minutes. We're just going to pretend. So, congratulations. You are now a professional lawnmower. Wow. Isn't that your dream job? You are a professional lawnmower. Yeah. Okay, Megan. So, any of those. Mow the lawn. Perfect. Megan is prepared. She's an expert at this. Okay. So let's say, how much do you want to charge per lawn? If somebody says, hey, what's your rate? How much would you charge me to mow the lawn? Woo, $300? Oh my goodness. $50. Okay, let's do $50. Ooh, Amari, I'm hiring you. $50. Okay. So yeah, it would depend on how big the lawn is, right? But let's just pretend in your neighborhood, every lawn is the same size. Okay, $50. So this is our equation, y equals 50x. So x here is going to be the number of lawns that I mow, right? So x is my independent variable because that's what changes, right? If I mow one lawn, I get $50. My y is 50. If I get to mow 3 lawns, now I earn $150. Okay, so my y is my dependent My x is my independent. Okay, now let's talk about something else. We've talked about domain and range a little bit. So my domain, remember, is my x values. Okay, so my domain is going to be all whole numbers, right? Like, I'm not going to say, I'm going to mow just half of your lawn. We're not going to mow half a lawn. That would be so weird. And people would not hire us if we just mowed half a lawn. So my domain is going to be all of whole numbers, right? Let's say max, we can mow 5 lawns a day. That it takes us a while. We've got to have lunch, gets dark. So we're saying, okay, we top out at 5 lawns a day. So my domain, all my possible x values would be either 1, 2, 3, 4, or 5. Okay, I'm not going to mow 1.73 yards, right? If I'm going to do, I'm either going to do 1 or I'm going to do 2. Okay, we're not going to halfway do something. So then my range is my y values. So when I mow 1 yard, y is 50. 2 yards, y is 100. 3 yards, 150. 4 yards, 200. 5 yards, 250. Okay, so our range changes based on what our x value is. Okay, so that's kind of to help you make that connection of, well, how come my range isn't just 1 to 5? Well, because we don't want to include numbers like 3.15, 3.27. Okay, we're not going to do 2.5 yards. Okay, so that's kind of that's going to help you on some of your domain and range problems that are coming up. All right, now we are going to all do this together. This is going to look overwhelming at first, but I'm going to cover these up. We have a bunch of really fun representations of relations, and we together are going to determine, is it a function or is it not a function? So the first one is a graph. And this is where we're going to be using the vertical line test. So let me draw myself a vertical line. Good, y'all are on it already. The very first one I try, I put it over these points and it crosses 2 times. Yep, so this one is not a function. Very good. All righty, what about this one? Take a look at this mapping. Tell me yes function or no, not a function, and then tell me why. Good, it's not a function. Excellent. Yes, 8 repeats on my mapping. 8 has 2 lines coming from it, not a function. Very good. All righty, take a look at this one. What do you think? Where's our vertical line? Let's bring it down here. So I would move this across. Am I ever hitting more than once? I'm not. Nope. So therefore, y'all are right. It is a function. Good job. All righty, what about this one? Good. This one is a function. Exactly. Very good. All righty. Here is a list of ordered pairs. What do you think? Function or not a function? Good. It is a function. That's right. X does not repeat. Even though it has the same y value for every single x, x doesn't repeat. So that is a function. Good job. All righty. What about this one? We'll use our vertical line here. Good. Y'all are not fooled. This one is a function. Good. Okay, take a look at this one, this mapping. What do you think? Good. It is actually not a function. So this one is kind of tricky because each of these x values only has one arrow coming from it, but they were sneaky and put this -6 in there twice. So therefore, it's not a function. All right, what do you think about this graph? Function or not a function? Exactly. Yep. If we move our vertical line over there, it hits that graph in more than one spot. Good job. All righty. Take a look at this bottom one. What do you think? Good. Y'all are getting good. All right. And what about this top one? Look at the x values. So 18, yes, 18 does repeat exactly. So this is not a function because of that. Very good. All right, we got two more. Take a look at this one. Good, not a function. Exactly, because 2 repeats. Awesome job. And the last one. What do you think? Function or not a function? Good. This one is a function. Very good. All righty. So now that you know how to determine if something is or is not a function, let's talk about evaluating a function. All right. So evaluate this function. Remember that ordered pairs are x and then y. Okay. Sometimes y is also listed as f of x. You'll see that in 2 slides a lot. So when x is 2, y is 7, exactly. So we can evaluate a function on a table. We can evaluate a function on a graph. So when x is -1, oh, that's +1. Sorry. -1, I would be writing this point here. So when x is -1, y is 4. Okay. So y'all fill out, we're going to do this will be number 1. So write out your ordered pair for number 1 and number 2. Good. Okay, so we're going to have exactly 0, 3, and 3, 2. Very good. All righty. So now let's talk about function notation. So you will see over here on the left-hand side kind of what I was talking about. Instead of all of this saying y equals, they're using function notation. The reason that we use function notation is because we get something that looks like this. It will say evaluate f of 15. So this was our original problem, f of x equals x. So now what I'm doing is f of 15. So instead of putting an x, I put 15 in for x. So everywhere in my equation, I'm going to replace x with 15. This one is easy. It's saying whatever x is, that's what y is too. So this answer would be 15. It's not that easy always. It's almost never that easy. So let's look at this one. I'm going to call it number 2. G of n equals n plus 4. So we want to evaluate g of 7. So I'm going to write it out. G of 7 equals, I go back to my original equation, 7, good, plus 4 Exactly. And then I just do my math. 7 plus 4 is 11. So what would number 3 be? H of 2. So I go to my original equation. H of 2 equals 3. Instead of x, I'm going to put 2. So 3 times 2 plus 5. Good. 3 times 2 is 6. 6 plus 5 is 11. Let's take a look at number 4. So R of 8 equals 1/2 times 8 plus 1. So I'm going to do half of 8, which gives me 4. 4 plus 1 gives me 5. Good. And then this last one is pretty easy, but we do f of 1. So we have 0.3978 times 1, which is still going to be 0.3978. Good, 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 good. Okay, do I have any volunteers that would want to try some of these? We're all going to do them, obviously, but anybody that wants to try them on the board. Awesome. AJ, I'm going to have you do this one. Mari, this one. Micah, this one. And then is it Marley? Marley or Merrily? Alrighty, there we go. Okay, I should have given y'all whiteboard tools. AJ, I didn't get yours yet. Just a second. I'll give you whiteboard tools. So if you could, if you're doing these on the board, go ahead and write out all the steps so that we can see exactly how you got it, okay? So if you're not doing it on the board, you're doing this on your own paper, and we're going to check. So I'm going to give you 2 minutes to do all 4 of these. Good. Good job, guys. This is looking good. So if we look at the one AJ did, she did H of 2 equals 5 plus 4 times X. X is now 2. So 4 times 2 is 8. And then she did 5 plus 8, which would be 13. Exactly. All righty. So then down here, we had given P of t equals t plus 1,589. We are going to put in 0 for t, so our answer stays at 1,589. Good job. All right, now let's take a look at this one at the top right in the red pen. Given that g of x equals negative 4 times x, evaluate g of 7. So that would be negative 4 times 7, which is beep, 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 negative 28. Awesome, awesome. And lastly, given that k of n equals negative n plus 1, now we're going to evaluate k of 5. So k of 5, we add that negative on there. Good job. That was kind of a tricky one. Negative 5 plus 1 is negative 4. Y'all did so awesome. Good job. Y'all tell them how awesome they did. Thank you so much for volunteering. I appreciate it. Okay, so now let's evaluate from a graph. We're going to find f of 5 and f of 0. So first we would remember this is plugged in for x. So we go to the x value of 5. We want to hit our graph. So f of 5, the x value is 5. Yep, x is 5. So then remember, this f of x is the same thing as y. Okay, so our answer is just going to be -3. Okay, and then if we wanted to write it as a ordered pair, it would be 5, -3. Okay, so now let's talk about f of 0 would be good, -4. Exactly. Good job. Okay, let's go. We're going to go on. I want to do, we just have a little bit of time left. Alrighty. So we talked a little bit about domain and range at the beginning of class when we talked about mowing grass. So what I want to talk about now is domain and range if you're given a word problem like this. So this says, Marisol is buying cupcakes for her daughter's birthday party. She will need at least 2 cupcakes, right? So she knows there's at least going to be 2 people there, but no more than 8. Cupcakes at the local grocery store cost $3 each. The function P of C equals 3 times C. C represents cupcakes, okay? And then P of C is the price, so how much she's going to spend. What is the domain and range of the function? Okay, so remember, domain is our x values or our independent. Okay, so be careful here because domain, we want to include all possible x values. So all possible quantities of cupcakes that she's going to buy. So remember, she needs at least 2, right? So she's going to buy either, this is a set, right? She's going to, exactly, good, Michael. She's either going to buy 2, 3, 4, 5, 6, 7, or 8. She's not going to buy 2.5. She's not going to buy 4.25, okay? Whole cupcakes. So she's either going to buy 2, 3, 4, 5, 6, 7, or 8 cupcakes. Our range is the y values. So we have to plug in the x value, plug in the domain to get the range. You don't buy that many cupcakes, Micah, that's right. That's why we have to use whole numbers as our domain. Okay, so let's plug in 2. 3 times 2 would be 6. So let's calculate the range. It would either be 6, 9, 12, 15, 18, 21, or 24. Okay? So you'll start to see some problems like this as we're moving into domain and range. Sometimes it's easy. Sometimes it's like, oh, anywhere from 2 to 8, and all numbers in between. Sometimes it's trickier. It's like this, where we cannot buy 4.25 cupcakes, right? So then it would change to just the whole numbers. Alrighty, so for our exit ticket today, you are going to tell me, you're going to send me a private message. Okay, if you don't know how to do that, it's the question mark. You're going to tell me for number 1, is this relation a function? Why or why not? So yes, it's a function because, or no, it's not a function because. And then you're going to tell me what's the value of f of -2. I don't know why that little arrow is on there. f of -2. And you're going to tell me what number you get for y. Good, AJ. Good job. Good, Aubrey. Good, Nola. Good, Micah. Good, Stevie. Good, Marilee. Good, Jasmine. Good, Ketsia. Close, AJ. So let's remember our order of operations on the bottom. Yes, Nate, good job. Good, Nola, you got it. So f of -2 is 2 times -2 squared minus 1. We're going to do exponents first. So you're going to do -2 squared. Remember, -2 squared is -2 times -2. Good, Micah. Good, Michael. That's right. Good, Sophia. Micah, check your math. Oh, you got it now. Good job. Good job. Good, Amare. Good job on both of them. Good, Sanaya. Very good. Good, Rami. AJ, check your math again. Remember, a negative times a negative becomes a positive. Aubrey, check your math. Close. A negative times a negative becomes a positive. So -2 times -2 is +4. There you go, AJ. Good job. So we would get 2 times 4 minus 1. And if y'all are confused, you can just put this in your calculator. Okay, so Nani, it is a function. So number 1 is a function because each of these x values is individual. None of those are repeating, and I don't have two numbers coming, or two pairs, two lines coming from one number. For number 2, 2 times 4 is 8. 8 minus 1 is 7. So if y'all got a negative number, it's probably because you did not account for -2 squared. Okay, negative times negative is a +4. 2 times +4 is +8, and then 8 minus 1 is 7. All right. So any questions for me before you go? Anybody have any questions over the lesson? Okay, Marilee, what are you confused about? Okay, so the way that I got 7, take a look at this first line right here. I plugged in -2 for x. So I'd get 2 parentheses -2 squared minus 1. When we plug something in or we substitute a number in, we always want to put it in parentheses. All right, so now if I follow my order of operations, the reason it turned into -2 is because it says right here to evaluate f of -2. So instead of f of x, it's going to be f of -2. So anywhere there was an x, it's going to become -2. So my order of operations is PEMDAS, right? So parentheses, I do have parentheses, but there's nothing to do inside the parentheses. Yeah, Nola, you're good. So no parentheses. E stands for exponents, and I do have exponents. So -2 squared is -2 times -2. A negative times a negative is a positive number. just a second, Ben, and I would love to go over that with you. Okay, so now I come back down here. So that would be 2 times 4 minus 1. Now I do multiplication or division, whichever comes first, and I have multiplication. 2 times 4 gives me 8. And then I subtract. 8 minus 1 is 7. Good. Okay, so Ben, let me look at your grades. Are there certain equations we have to follow? What do you mean that you have to follow? So, Michael, if you were putting it in the calculator and getting a negative, it's probably because you did not put your -2 when you put it in as like when you let me see if I can put my calculator. When you type it in your calculator, you have to put this -2 in parentheses. So you have to type it in 2 parentheses, -2, close your parentheses, squared. Because if you just type it in as 2 -2 squared, right? It's going to go ahead and multiply that. Because it just thinks that you didn't do it beforehand. Okay, but we're actually substituting something in here. So we have to put it in parentheses. Okay, so Ben, you are going to go log into ClassKick. Your ClassKick login is your TOPS email address. I'm going to send this to you. Hold on just 1 second, AJ, and I'll get to that. All right, so Ben, I'm going to send you this message. You are going to log into ClassKick. Your username is your TOPS email address, the full thing, and your password is your student ID number. So when you log in, you are going to get in there and take the beginning of the year assessment. It is 44 multiple choice questions. You're not supposed to know any of it. It's just for me to figure out if you know anything. You already did it. Okay, awesome. So then that is it for what was covered before you got here. There is a homework that is over what we just learned in ClassKick. So go ahead and log in to do that. It is called 2.01. So you're going to log in and complete that. When you've done it, go ahead and click raise your hands. Yeah, Micah, you can leave. Go ahead and raise your hand. Michael, you can send me a picture if you want of like you typing it in. Take a picture and email it to me and I can try to help you. Okay, so you're going to log in and do 2.01. Click the raise my hand button and then I will grade that hopefully this afternoon. Okay, so AJ, you were asking on the last slide, there was a list. Oh, okay, sorry. You were thinking that these were rules. Hold on, let me go back. This one. This is not rules. This is just I was just showing you function notation and how it works. They're not rules or anything. Yeah. Okay, Sanaya, let me see if I can, will you send me your student ID and I'm going to like reset it real quick for you. All right, let's go to your. Okay. Okay, Sanaya, will you log in real quick and see if that worked now that I already reset it? Is anyone else having trouble logging into ClassKick? If you don't have any questions, you are free to go. Y'all have a good day.